Good afternoon. So for today, we'll be discussing tangents and slopes and the increment method in solving for the derivative. So let's proceed. So what are the learning objectives for this module? It's to illustrate the tangent line to the graph of a function at a given point, apply the definition to find the derivative of the function, relate the derivative to the slope of the tangent line to the graph, and obtain derivative using the increment method. So you already know what a slope is, right? It's basically the inclination of a line. That's one of the properties of a line. So when you look at the figure in here, you can see that this one from point x1, y1 going to point x2, y2, it has a certain inclination. And that inclination is called a slope. So delta y, or basically y2 minus y1 is the change in y. Delta x, or basically x2 minus x1 is the change in x. So when you solve for delta y over delta x, that is actually what you call the slope, right? So all lines have slopes except for vertical lines. For vertical lines, they don't have slopes because the slope's undefined. Why? Because the denominator is 0. For vertical lines, the slope is undefined, pero for horizontal lines, the slope is equal to 0. Okay, so for tangent line problems, what is a tangent line first? So for example, guys, look at the curve here. You have here the curve y is equal to f of x. So in this case, if I pass a line, or if I have a line passing through only one point of the curve, that point is what they call the point of tangency. This line is called a tangent line. So given a point P, P has coordinates C and f of C, so basically x and y, and the point is on the function f of x, then there exists a tangent line. So basically, it's just the same, if I ask you, what is the slope of line PQ in here? So you're going to say, isn't it just delta y over delta x? Yes, because, for example, I'll write here. Let's just say that x1 is just letter C, and then x2 is simply C plus any change, any additional x. Therefore, here, on top, di ba, the slope is delta y over delta x. So the delta y would be, okay, the y2, which is here, f of c plus delta x, minus y1, which is simply f of c, over x2, which is this one, divided by x1. And then you'll notice that the c's cancel out at the bottom. You'll be left with simply delta x. It's just the same, guys. y2 minus y1 over x2 minus x1. The y number 1 is simply f of c. The y number 2 is simply f of c plus delta x. Next. So what do you notice, guys? This one, for example, from P to Q, this is what you call a secant line because it crosses at 2 points, right? And then as I move closer and closer, like let's just say, from Q, if I move closer and closer to letter P, such that the delta x becomes smaller and smaller, don't you notice that the slope decreases and decreases until it reaches that point only? Just for this example, you notice that from a secant line, it becomes a tangent line. So from 2 points, it becomes 1 point. That is the point of tangency. So basically, here, this is the definition of the slope. Here, this is still the slope. But then, that slope of the tangent line is basically the limit when delta x approaches 0. The slope of the tangent line of this one, of the curve, is this. So this is an example. So you'll notice here, the curve is like this, and then it starts with a secant line, 2 points. And when delta x becomes smaller and smaller and smaller until it becomes just 1 point of tangency, so it becomes a tangent line. This one also. So this one's the delta y is higher compared to delta x, but it since delta x becomes smaller and smaller and smaller, it still becomes a tangent line. Okay, so I want you to take note of the formula. Please take note of the formula. So basically, it's y2 minus y1 over delta x. And then the slope of the tangent line approximated at point P is basically the limit as delta x approaches 0 of that expression. So tangent line with slope m, it's the same. You know, I keep on, you know, showing this to you. Kaya lang ito, iba't ibang expression. The reason why I'm showing this to you is para you get used to seeing this, na ito, slope lang nakalagay, but then dito, that one, the right side is the slope. But that's also equivalent to the limit of delta y over delta x. And actually, this one is what you call the derivative eventually. When the limit as delta x approaches 0, when you evaluate that, that is actually the derivative. So let's try solving this. Find the slope of the tangent line to the graph of this one at 0.13. So how do we do this? So you know, you're given a point, you're given also the expression here, the function y equals the square root of the quantity x squared plus 3. So let's solve that. How do we solve that? So solve for the limit. Diba? So basically, ano ba yun? Approximate, diba? When x equals 1. So 1 plus any delta x. I don't know what that delta x is. I'm not given 2 points. Eh. If I gave you 2 points, it's easy for us. But I did not give you. It's okay. So that means the slope of the tangent line here is basically f of 1 plus delta x minus f of 1 all over this. So what do you do with that? You basically plug in 1 plus delta x for every x. And then here, 1 for every x. So do you get this point up to here? Okay. And then let's try to evaluate this. Paano naging ganito? Kasi sabi, when delta x approaches 0, edi ito, 0 na lang to. Diba? Magiging square root of 4. Diba? So paano to? Paano ba ito nakukuha? This one, I will show this to you in the next steps. So let's go to the derivative first. In the derivatives, the process of finding the derivative is called differentiation. I don't want to hear deriving. Deriving is for derivation, right? So for derivatives, it's differentiation. So a function is differentiable at x when its derivative exists at x and is differentiable on an open interval a and b, where it is differentiable at every point in the interval. And the derivative of a function of a real variable measures the sensitivity to change of a quantity, basically of a function, or dependent variable, which is determined by another quantity. Kaya nga, di ba, yung derivatives nyo, ratio siya. So parang, for example, this one, change of y with respect to the changes in x. So it's, you're basically measuring the changes with respect to one another. So, as I said earlier, you've been seeing this form. And then, the limit, as delta x approaches 0, sinabi natin, hindi ba slope yan? Yes, that's the slope. And that is also the derivative. So the derivative of f at x is defined by this formula, provided that the limit exists. For all x, which is this limit exists, f prime is a function of x. So Ano ba yung mga iba't ibang notations? Let's look at these. F prime of x is known as the first derivative of x. First derivative of f with respect to x. This is dy over dx. So most commonly, you will see me write it like this. Dy over dx or the y prime. But it's also the derivative of the quantity f of x with respect to x, the derivative of y with respect to x, or the derivative of y with respect to x. So these are some of the notations that we can see. And then going back to the slopes earlier here, when the limit as delta x approaches 0 of this or n of this term, that's actually the same as saying f prime of x or the derivative of y with respect to x. So ito, yung delta, that's capital D. Itong D na maliit, small d, right? So that's small changes, incremental changes. Whereas the delta malalaki. Kunyari, di ba pagka nagfi-physics tayo, for example, temperature from 100 degrees to 120, that's delta temperature. That's 120 minus 100. So that's 20 degrees. Whereas yung mga D natin, the small letter D, they are very, very small changes. So parang from 0.5 hanggang 0.5000001. So, you know, the change is very, very small. That when the derivative or the delta becomes very, very small, it approaches 0, it becomes a derivative. Kasi di ba, you know, for example, let's go to the definitions of average speed and instantaneous speed. For example, sinabi ko, you are traveling from point A to point B, you have traveled, let's just say, 60 kilometers in a span of 1 hour from 1 p.m. to 2 p.m. What is your average speed? E di ang sabihin natin, average speed is delta y, ay delta distance divided by delta time. So the delta distance is 60 kilometers. Ilan ba sabi ko? 60, no? Divided by 1 hour. So 60 kilometers an hour is your average speed. Tama? Pero, do you think that that speed is always the speed? Di ba hindi? Kasi, you have to remember, may mga stoplights and then there are cases where there might be pedestrian crossings where you've got to slow down. And if there are no vehicles naman, maybe you can speed up a bit. So, do you know what a speedometer is? Measures, is it average speed? Diba? What it tells you is your speed at that particular point. It gives you the instantaneous speed. So, the speedometer gives us the instantaneous speed. So, pwedeng sabihin na in the course of 1 p.m. up to 2 p.m., you were able to travel 60 kilometers, right? So, alam mo na 60 kilometers in 1 hour, okay ka na. Mabilis-bilis yung pagtakbo mo, 60 kilometers. Pero, at some point, nakita mo, bakit yung speedometer ko was registering 100. Pero nung nag-turn ako, yung nag-right turn or nag-left turn, syempre bumagal, naging parang 30 lang or 20. So, yung mga mini-measure nun are the instantaneous speeds at those particular instants. You understand? So, let's go to rate of change. Ito nga yun, no? The rate of change is the ratio of delta y over delta, baliktad tong nakasulat dito. I'll change this when I upload this. Delta y over delta x, which is the average rate of change over the interval delta x. So ito yung average. So ang rate of change pala na average is basically just the slope. Yes. Diba? But if delta x approaches 0, this ratio in general approaches a limiting value. Yun yung sinasabi ko na parang at that particular instant, diba? Time, yung time mo, delta t mo, 0 kasi at that instant eh. Diba? Hindi naman siya from 1 p.m. to 2 p.m. Hindi mo naman mineasure yung buo eh. Tinignan mo lang, ay ngayong oras na to, ano ba yung speed ko? Diba? Yun yung at those instances na parang wala siyang iba't ibang changes. Ito kasi malalaking change. So as the delta x approaches 0, it becomes a derivative. This becomes an instantaneous rate of change. So the limit delta x approaches 0 of delta y over delta x becomes a derivative. So let's discuss the increment method, basically the 4-step rule. Some people call it the 4-step rule, sometimes some call it 5-step rule, or I don't know. With me, it's just the increment method. So basically in this, you are given any function y equals f of x. You're required to give us the first derivative. So how do we do that? First, substitute x plus delta x for all the x's and y plus delta y for all the y in the function. Next, isolate delta y, or basically solve for delta y. Number 3, divide the whole equation by delta x. And then lastly, find the limit on both sides of the equation as delta x approaches 0. So, ito yung mga examples. I'll solve some. So for example, here, it says that the first step is change y to y plus delta y and x to x plus delta x. So let's go. Step number 1. All the x's becomes x plus delta x. All the y's become y plus delta y. So that's your first step. That becomes y plus delta y is equal to 2x plus delta x squared minus 5x plus delta x plus 3. So let's do this first. Let's try expanding. 2x squared plus 2x delta x plus delta x squared. This one we can immediately write 5 minus 5 delta x plus 3. So this is still y plus delta y, guys. You want to solve for delta y, right? So this one is 2x squared plus 4x delta x plus 2 delta x squared minus 5x minus 5 delta x plus 3 minus y. So were we able to solve for delta y na? Yes. Diba? So this one is actually step number 2. Solve for delta y. So let's simplify as we are solving. Delta y is basically, take note that what is y equal to, guys? What is y equal to? Diba the original problem is 2x squared minus 5x plus 3. That's the given. So that means here, 2x squared and 2x squared cancel out. Negative 5x and the 5x cancel out. The 3 and the 3 cancel out. Right? So the solved delta y is then 4x delta x plus 2 delta x squared minus 5 delta x. Okay, let's go to the third step. What was the third step, guys? Divide by delta x, both sides. So that means the left side becomes delta y over delta x. The right side becomes, I can isolate delta x, guys, so that it's not too much to look at. All over delta x. And then as I solve, maybe I can try canceling out some terms, those terms. So that means the simplified delta y over delta x is actually 4x plus 2 delta x minus 5. Can you follow so far, guys? All right. And then let's go to the last. The last is the limit as delta x approaches 0 of delta y over delta x. So in here, we will solve for the limit as delta x approaches 0 of delta y over delta x. So, yung ano raw, approaches 0. So that means this is 4x plus 2 times 0 minus 5. Am I correct? And when you're solving for the limit, guys, this one is actually changed to dy over dx. So that means the final answer, the derivative, is actually 4x minus 5. Okay. Sige, I'll solve 3 more examples. So, okay, what was the first rule, guys? First step? X changes to, and then the y changes to. All right. So let's answer this. So this becomes y plus delta y is equal to 3x plus delta x all over x plus delta x plus 1. So some of you might say, sir, wala na akong magagawa dito. Yan na lang ang meron ako eh. Unlike earlier. It's okay. So what we do here now is, let's go to step number 2. Isolate delta y. So when I isolate delta y, this becomes 3x plus 3 delta x all over x plus delta x plus 1 minus, isn't it that y is actually the original problem? Right? So some of you might ask, sir, that looks ugly. It's okay. Let's just combine them. Maybe we can do something about this. So x plus delta x plus 1, x plus 1. So when you multiply, that becomes 3x squared plus 3x plus 3x delta x plus 3 delta x minus, let's go to the second term, 3x minus 3x delta x minus, 3x squared minus 3x. Okay, so now that we have this, let's try simplifying what we can cancel out. 3x squared and 3x squared cancel out. 3x delta x and 3x delta x, and then 3x and 3x. So you're left with that term, 3 delta x all over x plus delta x plus 1 and x plus 1, right? So what is step number 3, guys? Diba? Obtain this form, divide everything by delta x. So that means delta y over delta x is equal to 3 delta x, x plus delta x plus 1, x plus 1. You will notice that you can cancel out terms. The delta x cancels out. And then, yan na lang, tapos na. So let's solve for the limit immediately. The derivative is actually the limit of delta y over delta x as delta x approaches 0. So let's solve for the limit. So dy over dx is basically of, so ito, this becomes 3 over x plus 0 plus 1, x plus 1. Okay, so that means dy over dx is simply 3 x plus 1 squared. Okay, so let's go to example number 4. Okay, step number 1 again. X to x plus delta x. Y to y plus delta y. So y plus delta y is basically square root of x plus delta x. Okay, wala na tayong magagawa. Let's go to step number 2. Isolate delta y. Therefore, delta y is basically square root of x plus delta x minus the square root of x. E di tapos, ang problem natin, guys, is number 3, divide everything by delta x, right? So when I divide that, x plus delta x minus square root of x all over delta x. So some of you might say, okay, tapos na natin nagawa. Number 4. The dy over dx is basically the limit as delta x approaches 0 of delta y over delta x. E di pwede na natin isolve. May problem. Look at this. I can say dy over dx is basically the limit as delta x approaches 0 of x plus delta x minus square root of x all over delta x. Look, guys, when I plug in delta x, what will happen to the top, guys? Isn't it going to be square root of x minus square root of x? So that becomes 0 over 0. This is indeterminate. So what do we do if it's like this? Maybe what we can do, guys, is, sige, I'll erase this, para I have some space. So that becomes 0 over 0. Indeterminate. What do I do? Maybe what I can do is I multiply by the conjugate. You multiply by the conjugate whenever it becomes like a 0 over 0 or something like minsan infinity over infinity. So look at the top. Since now I'm still not substituting, I should still write the limit expression. So the top becomes x plus delta x minus x. The bottom is delta x times the square root of x plus delta x plus square root of. Okay. So x and x cancel out. Oh, I'm left with delta x all over delta x, the square root of x plus delta x plus the square root of x. Okay, this one, I'm able to cancel out something. Magiging 1 na lang yun. And then now, I can apply the limits. Look, if I apply the limit, that becomes 1 over square root of x plus square root of x. The answer is 1 over 2 square root of x is your derivative of y with respect to x. Okay. Number 1, x to x plus delta x. Y going to y plus delta y. I know that for some of you will say, sir, ang answer dyan, cosine x. Yes, I understand. But we have to show this first. So y plus delta y is equal to sine of x plus delta x. Recalling your trigonometry, this is sin, cos, cosine. So sine x cosine delta x plus cos x sine delta x. All right. That's y plus delta y. Now we're finished. Let's go to step number 2. Let us isolate delta y. So in this case, your delta y is simply sine x cos delta x plus cos x sine delta x minus sine of x. Some of you will ask, where did I get the sine of x? That's actually the question. That's the original question. All right. And then before I do anything else with this, my question to you guys is, are there any similar terms? So some of you will say, sir, can we combine? Yes. So sine x, I have cosine delta x minus 1 plus cosine x sine delta x. And then let's go to the third step. As you said, you have to divide by delta x to obtain delta y over delta x. So I'll do that. Delta y over delta x is basically sine x cosine delta x minus 1 plus cos x sine delta x over. Do you notice a pattern? What is this, guys? So far, nothing canceled out. But let's go to number 4. Solve for the limit as delta x approaches 0 of delta y over delta x. Where did I get the cosine in here, guys? Kasi this one and that one. Sine x is the same, so I factored out sine x. I'm left with cosine delta x, right? And take note of this. Sin cos sin. This one is cos sin. You understand? For the upper sign, look at the upper sign. For the lower sign, look at the lower sign. It so happened that for cosine, it's minus. You understand? Okay. So let's solve for the limit. I can safely say that here, this one is dy over dx is, ito kasi wala namang delta x, so I can choose to bring sine x outside because the limit is for the delta x. Cosine delta x plus cosine x limit delta x approaches 0 of. Okay, guys, look at this. What is cosine delta x minus 1 all over delta x? Diba you had this already? I taught this to you last time. The squeeze theorem. This is equal to 0. This one whole thing here is equal to 1. So sine x times 0 is 0. Therefore, the final answer is dy over dx is simply cosine of x, just like what I said here. So that means whenever I give you sine and cosine, you will deal with squeeze theorem. You will have to apply that.